Hello, my name is Ian Alphonse, and today we're here to introduce you to our project, SureLock. So, to start things off, we should ask what SureLock is, right? Well, not so much. First, we should ask what the problem is. And the problem is theft.
Philadelphia, PA is the leading American city where smartphone loss is most common. There are 306 annual property crimes, and out of 13,133 people, 62 of them are robbed. The chances of being a victim in Coatesville are 1 in 36 people, and throughout Pennsylvania it is 1 in 49 people. In Coatesville, there are 76 burglaries, 225 thefts, and 59 car thefts. That's about 274 crimes per square mile each year.
So these are staggering results. So how do we approach this problem? Well, SureLock is a device that you place in your bag, and it is a motion-sensing alarm. So when it's tampered with, the alarm goes off, and the only one that can turn off that alarm is the user. This is done by a biometric sensor, an optical fingerprint sensor, that takes a picture of your finger and then puts it over a template. And then when that fingerprint matches the template, the alarm goes off. So here's our device. Hopefully it will work. The alarm goes off, and the alarm is off with my finger. So why did we develop this? I'd like to invite Kendall and Brooke to tell us the stories of theft in our schools.
I'm on the track and cross country team, and there have been multiple thefts occurring over the past few years. There's more faces and phones and tablets being stolen out of bags and lockers.
And in our locker room, we've also had drinks stolen out of bags and phones and any type of clothing. So we should all prevent that. So why would we do the SureLock? Well, again, it would be for theft, and we came up with the name based on Sherlock Holmes because he's a detective, and the SureLock helps with theft, so it can help prevent it.
And we strongly felt the device needed a fingerprint sensor to keep it uniquely personal to the user. So now I'd like to switch over to the development side. So first we started with the components. We wanted to choose the very best. For the microcontroller, we chose Arduino Micro, made by Adafruit. It's all open source and very well supported, so it has a whole set of libraries and components that we could use for the Arduino, such as the fingerprint sensor made by Sparkfun and the accelerometer made by Adafruit. And the accelerometer is how we made the motion detection activate, because it senses move in a very precise increment. Next, we went through the process of just picking the fingerprint sensor. We started with one made by Adafruit, but it overheated and broke, so we had to switch to the Sparkfun fingerprint sensor here. And it's very low profile. The other one was really big, and you'll see that in the next video in a couple slides. So organizing the information. So when we were trying to program this device, we just wanted to dive right into the programming, but that wasn't really a good idea. We kept getting lost in the code. So our mentor, Mr. Poulin, told us we should make a flowchart. So we did. So first the user presses the fingerprint sensor, and it checks for a match or a no match. If it's a match, it switches to the lock state and checks the accelerometer. And if the accelerometer is true, then it compares with the current, and if it is a match, it goes right back to the beginning. But if it's no match, the alarm sets off, and the only way to stop it is with your finger. So match or no match. If it's a no match, it just goes back to the alarm over and over and over again. So development testing. We went through various processes to get the device to work, from just checking the fingerprint sensor to make sure it even detected. As you see here, it didn't work, and then it started to work after we changed some code and some ports. We figured out that pin 4 and 5 didn't work on the, or didn't communicate with serial through the Arduino Micro like it does on the Arduino Uno, which is what basically everyone tests on. This was us testing the alarm function. And we switched from a piezo to an actual speaker, making a louder sound.
For the engineering, we're always having to change the design or something because it wasn't working right. So we would have to move some of the wires around. And after we finished the device, we were testing it to make sure it would work right. And then we needed a case, so we got a wooden one that was 4 inches long, 3 inches wide, and 2 inches deep. So all the components would fit in it nicely, and so it worked right.
So mass production, we needed to make this, we wanted to put this device into everyone's hands. So to do that, I'd like to invite Ollie for scalability.
So when we were coming out with scalability, we took in, we thought about these following considerations: the manufacturing and labor costs, the component costs, potential business partners, marketing costs, and distribution costs. And when we were looking for potential business partners, we looked for businesses that were located in Pennsylvania, and we found the following businesses. So for our first initial order, we'd make 1,000 units, and you can see the price per each unit and the unit total. So the total cost for each unit would be $36.01, and the order total would be $37,544.63.
So we partnered with Mr. David Pullen, and he's a metallurgical engineer.
We learned that Mr. Pullen worked at MedLab, and he was a lab manager, and he wrote work orders for shops that needed various alloys. The STEM skills that he used for metallurgy, which is used to change properties of metal alloys with the correct temperature and atmosphere. And he also used chemistry and heat transfer and thermodynamics.
So you have to take various STEM courses to make this career possible, such as engineering mechanics, just making sure the mechanics work. Physics, you need math and various things for metallurgy.
We need the physics to make sure that the machines would operate correctly and so it would be functioning right. And it needs theory of materials and materials so that you know what the different type of materials, how they react, and what the different materials are out there to use.
All right. So now with all that, we believe that with SureLock, there will be no crime to solve. Thank you.